So the first part of 6.4, we're just going to talk about something called the rhombus. Tomorrow, we are going to talk about rectangles and squares. So 6.4 is over 2 days. On Thursday, we'll do 6.5. Then we'll stop and review. That is actually as far as we're going to go in Chapter 6. So we will review a little next week as well. And you are set to have a test on Wednesday. That is not accurate. What? Yeah, the first page looks like this. So there's a box up at the top. We have school every day this week, besides yesterday. Yes. All right, so a rhombus. Here we go, guys. A rhombus is a parallelogram with 4 congruent sides. So ways you can tell something is a rhombus. Probably the easiest one is that all the sides will be labeled in the same way. They might also be labeled with a side length. All 4 sides would have the same length, like 5, 5, 5, and 5. Okay? So that's kind of the tip-off that something is a rhombus. All 4 sides are congruent. All right, here are the properties of a rhombus. Opposite sides are parallel. So a rhombus is a parallelogram. So everything we learned last week about parallelograms, opposite sides congruent, opposite angles congruent, diagonals bisect each other, all that stuff is still true. Okay? So the opposite sides are still going to be parallel. Instead of opposite sides congruent, technically opposite sides are still congruent, but all 4 sides are congruent. All right, and just like any other parallelogram, the opposite angles are congruent. That's nothing new. Consecutive angles are still supplementary, so those are the next door neighbor angles. Those add to 180, just like any other parallelogram. Same as last week, the diagonals bisect each other. And again, like any other parallelogram, alternate interior angles are congruent. That's what we used on our warm-up. This one is new. This is unique to a rhombus. The diagonals are perpendicular. So they bisect each other, they cut each other right in half, but they also make right angles. Now, the angles, like the original angles, when you put a diagonal, those get bisected. So it bisects the angles. And they bisect each other. And they're perpendicular. So those diagonals are super important in these. So this big arrow is just saying, we learned a few chapters ago that perpendicular lines form 4 right angles. So this is just saying you can put that box to show that all of the angles are right angles. Example 1 says, the following quadrilaterals are rhombuses. Find the value of the variable. What do I know about the sides of a rhombus? They're all equal. So I can set those 2 expressions equal. So 4x plus 8 equals 20. Now, last week on a parallelogram, you might be saying, well, we already did this. We knew the opposite sides, so the sides across from each other. But with a rhombus, any of the combinations, any of the 4 sides are equal. How would I solve this? Subtract the 8. Good. Divide by the 4, and you are absolutely correct. We get a 3.
And that's the answer.
This one's it's kind of hard to see what segments we're talking about. So the 2x plus 14, that's this segment right here. Okay? And the 4x plus 2 is this segment right here. So they're along the same diagonal. So what do I know about them? They equal each other because the diagonals bisect one another. So in a quadrilateral, if we have a rhombus, the diagonals bisect each other. This could actually say a parallelogram, because remember this was a rule last week too. But anyway, I won't get technical on you. What?
That's the answer.
What did you get for your answer?
6.
I think I agree. We're going to subtract 2x from both sides.
She thinks.
What is all? There's a lot of noises happening. Shh. Settle in. All right, so we have 2x plus 2. Subtract the 2. Divide by a 2. And yes, it is indeed 6. Okay, so you need to add the 30-degree angle on yours. Now, what do I know about consecutive angles?
They're consecutive.
Consecutive angles are supplementary. So I am going to write an equation where these two angles add to what? 180. Supplementary means add to 180. Okay, so I am going to subtract 30 from both sides. All right. And we'll need a calculator on this one.
12.5.
We get x equals 12.5. Now, what if they would have given us this angle over here instead? Then you make them equal. Good. So across are equal. Next door add to 180. All right, so we have another rhombus. Where do you see any information to indicate that this is a square?
Because it got all the angles.
Oh my gosh, you have been in geometry way too long to say because that's how it looks.
It's a cube.
The only there is nothing that indicates that those are 90-degree angles. They have to be labeled.
It's a box.
It's a rhombus. You have to go with the information you're given. Now, luckily, if this was a square, we'd do it the exact same way. But I can't let that slide that you guys say square when there is nothing to indicate that this is a square. The only thing we know is that this is a rhombus.
It's just obvious.
What do I know about the sides of a rhombus? They're congruent. So I'm going to make them equal. Then what? Add 3 to both sides.
Divided by 7 is 4.
Very good.
Too smart.
Are these angles supplementary angles like we looked at number 3? No. These are across from each other. These are opposite angles. And opposite angles in any parallelogram, including a rhombus, are what? Congruent. So I am going to write an equation making these angles equal to one another. Then I'm going to collect my x's. Then I'm going to add 10. And x equals 16. Okay, what do I know about the diagonals? That's going to be a good clue. They're congruent. They also, well, they bisect each other, so the sides are congruent. The alternate interior angles are congruent, so that's a good clue. We got a 50 over here. What about these angles? These are all
Vertical. Right? Linear. Vertical or linear?
these are all
Right angles.
right angles. Yes, in a rhombus. Okay. In a rhombus, the diagonals are congruent. They bisect each other, so the sides are congruent. This guy and this guy. This guy and this guy. But they also make right angles. Okay? And they bisect the angles. So if this angle is 50, what is this angle? 50. Okay? And, hold on, alternate interiors are congruent. So now we have this guy's 50 as well. Okay, what was your question?
Okay, sorry for calling you a
It's okay.
So when you don't have like a number like in the middle, you just automatically do the right angle thing.
If it's a rhombus, this does not work for a regular parallelogram. So like So like the warm-up problem, we could not do this because it wasn't a rhombus, it was just a parallelogram. When it's a rhombus, these are all right angles. Okay, so let's focus in on one of the triangles. Okay, I have a 50, I have a 90. How am I going to find this last one? Yes. Okay. So now, if this guy is 40, I know that this angle is being bisected, so this one's also 40. Alternate interior angles are congruent, so this guy is 40 and this guy is 40, okay? So just like the warm-up, we're not done. We have to fill in all this information. Yes, question. Because in a rhombus, the diagonals bisect one another. So when we have a rhombus, these are all right angles. It's one of the properties we wrote down on the last page about a rhombus. All right, now I'm going to trace these angles. I'll use a highlighter like I did earlier. So FHG, so this guy. 50.
Your street's a little big.
All right.
Wait, can you explain
What? Which part are you confused about?
like that? Like how
Wow, baby.
So did you get where I labeled all the angles?
Yeah.
Okay, so I'm just following these three letters to figure out what angle I'm talking about. So start at F, go to H, go out to G. What angle is that tracing? It's tracing this 50 degree angle. If this part's confusing you, get a highlighter and do exactly what I'm doing. All right. Okay, EGH. So start up at E. G. Out through H. That's 40. Okay. EJH. So yeah, that's one of those angles in the middle. So we talked about those are all 90. Why are you talking?
My bad.
All right, and the last one, HJG. HJG is also 90, right?
Yes.
Okay, a few of you have asked me this, and I still hear some confusion. In a rhombus, the diagonals bisect each other. Bisects means makes four right angles. So as soon as you see it's a rhombus with diagonals, you can put the box in the middle. Okay? All right angles. We are going to stop the notes here because this is where it transitions to the square rectangle stuff. That's where we're going to start tomorrow. So I'm going to give you your rhombus assignment today. We'll pick it up tomorrow.